Our next project will be a CRUD decentralized application. CRUD stands for Create, Read, Update, and Delete, which are the 4 basic operations of persistent storage. This is foundational and will help you understand data handling, smart contracts, front-end integration, and blockchain transactions. These skills are not only essential for blockchain development, but also highly adaptable to various real-world applications. These skills can be transferred to any sector needing decentralized solutions, like finance, healthcare, and more. Understanding CRUD operations on Solana allows for innovation, as you can modify or extend your application with more complex features in the future. So let's get started. Okay, so we're going to get started with using the npx create Solana dapp command because we're going to be creating a backend connected to a frontend. And this scaffold has your anchor program with a basic counter program, and it's already connected to a frontend for you using Next.js and Tailwind. So let's start that. We'll type into our terminal npx create Solana dapp, and you'll be prompted to enter your project name. So we'll just name this CRUD app. Oh, already exists. I've done this before. So we'll name it CRUD app 2. So we'll select a preset, Next.js, and we're going to use Tailwind for our UI library. And then here you can select an anchor template. So we'll do the anchor counter program with tests. And now it's going to be creating the workspace for you. This is going to take just a second to load, so we'll just wait for it to load. Okay, so now you can see that your scaffold is loaded, and you can actually see there's a command here that says found anchor version 30.1, please upgrade. So this scaffold currently is set to anchor 30.0, so we just want to make sure that we're on the latest version of anchor. So let's open up the scaffold. And here is your anchor folder, and the anchor folder is going to have all of your backend smart contract code. And for the front end, you'll have the web folder. So we'll touch the web folder later on. We're going to focus on anchor right now. As we just talked about, we need to update our anchor version. So we'll go into the cargo toml and update to the latest anchor. So here you see anchor lang is set to 30.0. We'll just update that to 30.1. And now looking through the anchor directory, if you go into programs, counter, source, lib.rs, that is where your smart contract lives. And what we're going to do is just update the counter to our CRUD app. So we're going to rename this to be a CRUD app. And then in the librs, with this preset, you have a working counter. So you have close, decrement, increment, initialize, and set instructions. Since we're updating this to a CRUD app, we don't need it. So we're just going to delete all of our instructions here and just have the basic layout for a smart contract using anchor. And if you see all of these data structures underneath, they're all related to the counter program, so we can delete that as well. And now we have a basic layout. We're using anchor lang from our crate. And then this declare ID has a generated public key. This public key is going to be the program ID of the anchor program that you deploy on chain. So this will always be your program ID. When you run anchor build, it's going to update accordingly. Inside the program macro is where all of your instructions are going to live. So that's where we'll write the CRUD app instructions. But first, anytime I write a smart contract, I always want to start with the program state. And the state is where you're going to hold all of your data. So as you know, smart contracts on Solana are stateless. So all of the state is stored inside program accounts. So we're going to create an account for the CRUD app and define all of the data that we want to store. To do that, you can use the account macro with anchor. So we're going to specify an account here. And then we're going to define the data structure. So I want this to be my journal entry state. Okay. Now, we're doing a journal here just because that's a very basic example of a CRUD app. In a journal, you want to create journal entries, you want to be able to update them if you need to, and be able to delete them if you need to. So We're just using a journal as our example. And let's see, what do we want to save to the state of a journal? We want to know the owner of the journal, so we can save that. And an owner is going to be of a type pub key because it's connected to your wallet address. When you're writing a journal, usually title it and you have a message. So let's save those as well. And these will be of type string. Okay. Now, when you're creating a account on chain and you have storage, you have to pay to hold that storage on chain based on how much space it takes up. So the rent is directly correlated to the space on chain. So we have to calculate how much space our state data structure is going to take up on chain. You could do this manually. Each type has a different number for how much space it takes up on chain, but Anchor actually does this for you. So we can use the derive init space macro to be able to calculate how much space is on chain. And you can see when we do this, we generate 2 errors, and the errors are for the string types. This is because strings can be infinitely long. So that's a little hard to calculate space there. So we need to set a max length for each string value. So for the title, that can be a little smaller. I'm going to set the max length of 50. Okay. And then you can see the error goes away. And I'll set a max length for message as well. And we'll say 1,000. Maybe you want a really long message. Okay, and now that error went away. So this is our state. Our state's defined. This is everything that we'll need to store for a journal entry, and it's going to live inside our journal entry account. We need to create this account. We need an instruction to initialize a journal entry account. So that's what we're going to do next. That will be our first instruction handler. We're going to do a pub fn create journal entry. Whenever you're writing an instruction for Anchor, the very first parameter that needs to pass through the instruction is going to be your context. The context macro is used to define a struct that encapsulates all the accounts that'll be passed through a given instruction handler. So we're going to write a custom struct for this instruction. So we'll write the context. And then we'll name the struct create entry. Okay. Just setting up the instruction here, we'll write the logic after we define our struct for this context. So we can go back down here and define that. Now that we have the instruction, we're going to define the struct for create entry. So pub struct create entry. When you're defining your context data structure, you need to define all of the accounts that are going to be passed through the given instruction that you're writing. So the first account that we're going to need is the journal entry account, and that is for the state that we just defined earlier. So to do that, you can use the Anchor account macro, and then we're going to add some constraints on the account for how we want to handle this account throughout the instruction. So the first thing we want to do is we want to initialize the account. We're initializing the account because it doesn't exist yet. So we'll use the init constraint. And then we want to have a PDA on this account. So we're going to define the seeds for this PDA. So there's about infinite ways that you could define a PDA. Here, I think that the best way for us to do it is specifying the owner and then another parameter. And that's because we want to know who each journal entry belongs to. So having the owner connected to the PDA is a really easy way to derive that. If we just had the owner, the owner wouldn't be able to create more than one entry on chain. We need to add another parameter to allow them to create more than one entry. So we can do this by adding the title. So if we add the title, the owner can go in and create multiple entries based on the title. We're just going to add that for receipts. We'll do title as bytes. And then we'll add in the owner's key. As ref. And now our seeds are defined. Anytime you define a seed, you always have to add the bump, so we'll add that here. And now, since we're initializing an account, we have to be able to calculate the space that it's going to take up on chain. This is needed so we know how much rent that we have to pay. So we're going to define the space. And whenever you're calculating space, you always start with 8. 8 is the anchor discriminator. So we'll add 8. And then for the rest of the values in the given journal entry struct, we can just calculate that by using init space, since we use the derive init space macro here. So we'll do journal entry state, init space. Okay. And now, lastly, we just need to define who's going to pay the rent. So we need a payer. And we'll make the payer the owner of the journal entry. And then all that's left here is to name this account. So we'll make this a journal entry of account, and it's going to be using the journal entry state. Now that we define that the payer is owner, we haven't specified who the owner is yet. So we're going to do that next as the next account in our create entry struct. So we're going to, once again, use the account macro from Anchor. And we're going to specify who the owner is. So in our case, we want the owner to be the person who's signing the instruction. So it's just going to be the signer. Now, if you look at how our accounts are set up, we have the owner being the payer when we're initializing the journal entry. Because the owner is going to be paying, it's going to be changing the state of the owner's account. When that happens, we have to define that the account's mutable. So we're going to add the mutes constraint here on the account. And this is just because in Rust, all variables are immutable by default. So whenever we want something to be mutable, we have to specify it. And then lastly, we just have to define the system program. So system program, and we're good to go. So now you can see we have one error showing up on the account, and that's for title. Now, why is that happening? It's because we haven't specified what the title is yet. And we don't know what the title is going to be. So the title has to be a user input parameter. So we're going to go back up to the instruction, and we're going to add a parameter for title. And that'll be of type string. Okay. And now, this is being passed through the instruction, but it's not being passed to this create entry struct. So to be able to get this data down here, we're going to have to specify that you're pulling the title from the instruction. And we can do that by using the instruction macro. So instruction, and we're passing through the title that's coming through from the instruction user input parameter. So now we're good to go for everything needed for our context data structure for the create journal entry instruction. Now we can go in and start writing our logic. So if we look at the instruction, we're passing through the context, always the first parameter. We're passing through a title, which is a user input value. And then there's one more thing that the user is going to be inputting on the front end, and that's going to be the message for their journal. So we're going to add that as another parameter. And that's everything we need there. So all that's left is just defining the logic for the instruction. And what are we doing when we're creating a journal entry? We're just saving information back to the account state. So that's all we have to do here. To do that, we're going to load in the journal entry account. So we'll let the journal entry equal. And we're making this account mutable because we're going to be changing information in the account. So mutable, and we can load that in through the context. So we'll do context.accounts, And the account that we want here is the journal entry. So you can see here, this is the journal entry account that we're loading in through our context. And Copilot knew what we were doing and just finished everything. So we'll talk through what Copilot just did here. We have our journal entry. And then all you're doing is updating the fields on the journal entry. So the journal entry owner, we're referencing the owner's key. And the owner, as we've defined here, is the signer of the instruction. We have the title and the message, which are both user input parameters of the instruction. And that's everything we need to save. So our very first create instruction is completed. So we can move on to the next. So a CURD app, create, read, update, delete. Read is just querying the blockchain. So we're going to move on to update. And we're going to do an update journal entry. Okay, so as you can see here, Copilot is really great and already knows what needs to be done for this instruction. So I just tabbed over through the Copilot suggestion, but we have the update journal entry. The very first parameter that's being passed through is the context. Now we need to define what this data structure is for the context. So let's go down here and do the same thing we did earlier, but now we're going to be doing it for update entry. So derive accounts macro. And then we're going to do, update entry. Okay, here with the data structure, you want to define all of the accounts that are correlated to the instruction that you want to have the data structure for. So we need to pass through the first account. That account is going to be the journal entry account. So let's define that here. And we'll use the account macro. And we'll add some constraints to it. So here the constraints are going to be a little different. It's already been initialized, so we don't need the init constraint. But we're going to be changing the state. So we need it to be mutable. So we'll define mute as a constraint. And then you always have to add in the seeds so it's able to derive the correct PDA of the account. So we'll do the seeds and the bump. And here the seeds should be the same as above, title and the owner's public key. And now there's one more thing that we have to do. As we talked about earlier, the rent for storage on chain is calculated based on how much space it takes up. So if we're changing the length of the title or the length of the message, it's going to change the amount of rent that a user needs to pay for space. So let's say we had a message that was only 10 characters long, and I want to go in and make it 100 characters long. I now have to pay more rent. And vice versa. Let's say I deleted 100 characters. Now I'm paying less rent and I want to get those extra land ports returned back to my account. So to do that, we're going to use the realloc constraint. And this is just reallocating space for a specific account on chain. So we're going to calculate the space here. So we'll do realloc equals and have the new space calculated. So 8 is the discriminator. And then we'll do the journal entry init space. And then whenever we're doing this, we still need to specify who is going to either receive the extra land ports that are being returned or pay more land ports that need to be given for more space. So we'll do realloc payer. And that payer is once again going to be the owner. And there's one more thing. So we can do realloc 0. And what this is doing is just setting the original calculation of space back to 0 and then recalculating everything. So we'll set realloc 0 to true. And then lastly, we're just going to define what this account is. So it's our journal entry account. Okay. Now, if you remember from before, this data structure doesn't know what title is. So we're going to have to do the same instruction title. So we'll pull that macro in. And then we're going to add that as a parameter here for updating journal. So title is also going to be a user input parameter for the instruction. So now we specified the owner, but we need to pass that account through as well. So we'll add that in. Same thing as we did earlier. So it needs to be mutable because it's going to be paying. And it'll be the owner, and the owner is the signer. And then the very last thing we have to pass through is the system program. And now our data structure for our update entry context is completed. So we can pass that through here for our update journal entry instruction. If you look at the instruction, we have this little warning under title. And that's happening because title isn't actually being used in the logic of this function. This is just a little Rust thing. We're going to just add an underscore here to say, hey, I know that this parameter isn't being used in the logic, but I need to use it somewhere else, so I still need to take it in. Everything here is done. We have our update journal entry. We're passing through both the title and the message. We're updating the message in our journal entry state, and we're passing through all of the corresponding accounts in our update entry data structure for our context. Creating the journal is done. Updating the journal is done. So all we have left is to delete a journal entry. So we can go in here and we're going to write out our instruction for deleting. Okay. So this time, Copilot has been doing pretty well, but this time it's not correct. So we're going to delete what it suggested here and just have this instruction returning an OK value. And that's going to happen because all of the logic for deleting an account on chain is going to take place inside the delete entry data structure for the context. That's because all it's doing is handling accounts, and all of the account handling takes place inside the data structure. We'll go down here and make another struct for deleting an entry. Okay, first account we're loading in, just like before, is our journal entry account. So we'll do the account macro. We're changing the account state, so it's mutable. We need to specify the seeds and the bump, so it's able to derive the correct PDA. So seeds, the same as earlier, bump. And then there's one last constraint we're going to add, and we're going to add a close constraint. So what close does is if you run this instruction, it's going to close the account. But it's only going to close the account if the public key that I specify the close to be equal to is the signer of the instruction. So I want the person that can close this to only be the owner of the account. So close equals owner. And we'll do define the journal entry. And then we're going to specify who the owner is, which is the signer. Okay. And then lastly, we pass through our system program. And then one last thing to pass through is the title, just like we did earlier. So we'll pull this macro down here and then make sure title is passed through, which it is. And look at that. Our program's done. So if you go here, you can see the create, update, and delete entries are completed in our program instructions. And you can see this little warning here for context, and that's coming up just like earlier with title. It's because context isn't being used in the logic. So we're just going to add an underscore here and say, hey, I know that, but I'm using it somewhere else. And then we have all of our context data structures for create, update, and delete. And then we have our state. And that's everything we need for a CRUD app. So we'll go in and we're going to build the program. So if I cd into my Anchor directory, I can just run Anchor build. Make sure everything builds correctly and compiles. Okay, so now you can see our program compiled, everything finished, and we didn't have any issues. If something goes wrong within your program, the Anchor compiler will be able to pick it up, give you a warning, show you how to fix it most of the time. But we have everything correctly done and built. Now that that's built, what happens is it builds and sends an IDL to your target folder here. So you can see that this is my new IDL. And this is named a counter still because I did not update the name in the cargo toml. So we're just going to go in there and update it to CRUD app. So we're just rebuilding with the name CRUD, just so we can have everything named the same throughout the application. Okay, now we're good to go. So once we build the program, we're able to now deploy it on chain. Throughout this bootcamp, we're going to be using everything local. So I'm going to open up my terminal and run a local validator so we can deploy to our local host. So here's my terminal. And to get your local validator running, you're just going to run Solana test validator. And we're now initializing an instance of the local host. And you can see that the validator is running on my local host right there. So now that this is running, I can go in to my terminal within the CRUD app directory and do Anchor deploy. And I'm going to specify that I want it on local. So we're going to do provider.cluster local host. Okay, it's actually local net for Anchor. So if you're using the Solana CLI, it's local host. If you're using Anchor, it's local net. That's one fun fact to remember there. So you can see it's deployed. We have our program ID here. One thing to always double check is to make sure all of your program ID keys are synced throughout the workspace. So now that it's deployed, we're just going to run Anchor keys sync. And you can see all program ID declarations are synced. Now that it's deployed, we're able to connect this program to a front end. So let's go into, we can close out the Anchor folders and we're going to go into the web folders. So in our web folder, in the npx create Solana DApp scaffold, we have app, we have components, and we're going to be working between those two folders. So first, we're going to go into components and we're going to go to counter. And we'll go to data access. So we're just going to make some updates here. This was previously created for the Anchor counter program that comes with the scaffold. So this is just updating. It's fetching all of the information from the state. So we're changing the state from counter to journal entry. And we're going to do that everywhere. You can see that we have instructions from the counter, like close and increment and decrement. All of those can be deleted, and we're going to rewrite them for the instructions for the CRUD app. So we'll go in here. The close mutation can go away. The decrement mutation can go away. And you can see that it's returning an error because it's not finding these instructions in the corresponding IDO. So TypeScript knows that something has changed, and we just have to update those changes. Okay. There you go. Now we can just go in here and we're going to do our create entry. And we're going to use a mutation. And now we're going to be collecting information from the front end that's a user input value. So we're going to need to specify what's being collected. We're going to need to make this an async await so it's able to take everything from the front end and then pass it through. So we'll do we'll set up our create entry args, and that's going to have to be an interface that we're going to define outside of this. We'll do an interface for create entry args. And that is going to be the title that we need to pass through, which is a string type. The message, which is also a string. Then the owner, which is a public key. This initialize can also go away. Everything that's related to the counter can just be erased. Okay. So since creating the entry is part of the overall journal program and you're initializing a new account, we're actually going to have that in the use program. So we can go in here and do const create entry. We're going to use the mutation with the create entry args. We'll need to specify the mutation key. Oops. This is just a journal entry. And then we have create and we have the cluster. And then we'll define the function. And this is going to be an async function. And what we're grabbing from the front end is going to be the title, the message, and the owner. And now all we're going to do is return the program method for creating a journal. We can delete this return that happened earlier. Create journal entry. And then RPC to send the transaction. So that's what we're doing. We have the program methods. We're calling the create journal entry instruction, and we're passing through the title and the message from the user input parameters that we're grabbing from the front end. Now, since this is an async function, we just want to have an on success and an on error. So we'll add that in. Success. So if this is successful, it's just going to sign the transaction. And then refetch all of the accounts for the program. And then if there's an error, we'll add the logic in for that. and just make sure we return the error message. Okay, so that's everything we need for create entry, and then we just need to return that. So we're returning our program, our get program accounts, and our create entry. So everything's set up to be able to use the program. Now we want to go into using a specific account. So what this use program is doing is just initializing a new account. If you want to update an account that already exists, we need to derive it from the PDA and then be able to go in and update it. So that's going to be the second function here, which is using an account. So we'll update that. We're able to query specific accounts. And now we want to be able to update an entry. So once again, we're taking the user input from the front end and adding in the create entry args that we specified earlier. And we'll need, let's see what Copilot did. So we have the mutation key for the journal entry. We're specifying that it's update and we're using the cluster. Now we need to specify the function. It's an async function. We're taking in the title and the message and the owner from the front end. And then here we're doing update entry. And actually, in this case, we don't need the owner, so we can delete that. And we're just taking in the title and the message. And then we want to have an on success and an error case, and that's defined here. If it's successful, it's going to sign the transaction. If it's not, it's going to return the error. And looks like that's good to go. Okay. And then last, we just want to do the delete entry. So we'll add another constant in here for delete entry. Okay, let's see what Copilot did. We have the mutation key, we have journal, delete, and the cluster. It's an async. However, yeah, we don't need to take anything in from the front end. We're going to take the program. This should be program methods, not RPC. Copilot was close. Delete journal entry. And we're going to need to take in the title from the front end, and the title is needed to be able to derive the PDA. So we'll take that in. Okay. So we have our function of the delete entry. It's taking in the title as a parameter. That's part of our async function here. Actually, there's a way we can do this without making it an async. If the card already exists on the front end, it will have what the title is. So it can just pull that without needing to be a user input value. So we can remove the need for an async here and just have the title. So the title will be already on the front end. You'll have it on the card. And when you click delete, it'll know which journal entry it's corresponding to. So we have the title, the program methods, delete entry, passing through the title here. And then there we go. So we have our signature. On success, it's going to be a transaction. And accounts refresh, we don't need an error. And we actually don't need this. This is what Copilot generated. But since we're only passing through the title, we don't need the create entry args. So yeah, we're good to go there. Now all we need to do is return these constants. And now everything's updated on the front end. So in the front end, we have things separated by accessing data through our smart contracts. All of the data access is completed. Now we just want to update that data on the UI side. We'll go into the UI file and we're going to update all of the information here. So let's see, we still need our key pair connected. We won't need the memo. We can get rid of that. So we're going to change a few things here. So this first counter card, it's actually going to be for creating a journal. So we're going to want to have the user input fields here. This is where we're actually going to grab the data from the front end. So we're going to want to have our title and a way to set the title. And we'll import useState from React. And we'll do the same thing for message. And then we're going to want to use our create entry instruction that we just created from the data access file. So we'll pull that in. And then we also want to be able to use a public key. So and this we're going to use from use wallet. And this is coming from the wallet adapter library. We have our front end. We need to have the title and the message be a user input. So we want to make sure that these values are actually input correctly from the user. So we're just going to have a check here. So we're going to do is form valid. And that's going to make sure that the title exists. And the message exists. And then we want to be able to handle the submit of the information on the front end. So we'll make a function for that. So if there's a public key connected on the front end and the form is valid, then we're going to be able to execute the create entry logic. Okay. And that's all we need there to handle the submit. So we need to do one more error handling, and that's going to be if there isn't a public key connected, we need to return that the user needs to connect their wallet. So we'll do an if there's no public key, we will return connect your wallet. Okay. Great. So now all we're doing is just handling the UI side of things. So when we return, we can delete everything that came with the counter because we are not going to need that. Okay. So when we return, we want to have an input for text. We want to have a text area for the message. And then we want to have a button for someone to submit. So we'll do a div have an input, and that input is going to be of a text type. Oh, there we go. So Copilot has it. We need the text type, we need the placeholder is going to be the title, the value is going to be title, and on change it's going to set the title by using the useState from React. So that's good for the input, and I'm just going to add in the class name actually, just so it sticks with the styling for the rest of this. We have our input bordered, I want it full, and I also want max width extra small. There we go. Okay, so input is done. Now we need a text area input as well. So we'll do text area. And then Copilot has it. We have placeholder message. The value that the user is going to input is the message. On change, it's going to set the message in the state. And then we have our class name. So we have a text area bordered. And then I also still want to add in the max. There we go. So text area is done. And then lastly, we need a button. So we have our button, and let's see. On click, we want to handle submit. We want to have it disabled if the form is not valid. And we also want to add in if create entry is pending. Oops. So is pending or is form valid, it'll be disabled. We have the class name is going to be a button. I don't want it to be a primary button here, so let's change that. So we'll do a small button. There we go. Okay. And then we just need to close our div, and then this section is good to go. So okay. So this is done. So what this is doing here is the card to be able to create new journal entries. Now we just need our last UI update, which is going to be the card of a specific journal entry and how to update a specific journal entry. So that's our create. Now we'll go to the list. So in the card, you can see it has all of the counter information from before. So we're going to delete that. And we'll delete the memo because we don't need it. Actually, we'll delete all of this. Just get rid of it. Okay. Great. So in the card, we're passing through the account query. We're going to pass through update entry and delete entry. And that's going to be from the program account. And it's going to be passing through the account. And now we're going to have the public key. So we'll do the use wallet just like we did earlier. Public key. There we go. Okay. And now, just like we did earlier, we need to set the message because a user is going to be able to go in and update a message. So they need to have that space to update it, and we need to be collecting it on the state. So const message and set message. And we'll do use state. Okay. This was the optimization we talked about in the contract. It doesn't need to be a user input value. We're actually just querying it from the account. And the title cannot be updated. It's just there because it's part of the PDA for an account. So we'll just add in title, and that's going to be an account query. Okay. And I spelled const wrong, so we'll fix that. Great. So we have our public key, our message, our title. And then we'll do the same is form valid check. So we'll just copy that over. We don't need to retype it. But actually here we're not having a title. So we'll just update this to only be for message. Okay. And then we also need the handle submit. So we can copy that as well. Just some less typing. And we'll need the public key, so while we're up here, we'll copy that as well. So here we go. Handle submit, public key. And now, let's delete this. Everything related to the counter, we're just deleting. Now we can do our return. And this is going to be an account query. And it's just going to load all of the accounts associated with the program. This is just going to be a lot of UI work. So we're going to span class name loading. There we go. And then else we're going to return the card. So let's actually see what Copilot did. So we have the class name card. We're going to just make this a little fancier. So let's make it a bordered card. Border base, let's do like 300. And then spelling things wrong. Okay. So class is done. And now we're going to do the card body. We'll just center things here. Okay. We'll do this a little differently. Okay. So we're going to do the class name. We'll just add a space in here. Okay. And now we have our header. We have a card title. We'll center the card title. Okay. And now we're also just going to want to add in a refresh here. So on click, it's going to refetch all of the account queries. So on click, we're going to do accounts query, refetch. There you go. And if you're following along and see things auto-completing here, it's just Copilot. I'm going to change what Copilot did a little here. So this is actually going to be an account query for the title. Okay. Clean up some code a little bit. So we have our title here for the card. And now we have the title. We're going to want to add in the message. So we'll just add that underneath. So let's delete this Copilot recommendation and just add in the message. And this will be an account query as well. Okay. Great. So that's done. Now just visualizing the card, we have the title at the top of the card, we have the message displaying. Now, since we want to be able to update a journal entry, we want to have some space for a user to type in their updated message and a button to click that. So we're going to add that in. It looks like Copilot did a pretty good job here. So let's just go over. We have our card actions. We'll just add a justify here. Just clean up the UI a little bit. Okay. And then we have our text. We'll change this to a text area. Text area is going to have a placeholder for message. It's going to have the message value. On change, it'll set the message. And then we'll do a class name. And there we go. So there's our text area. And then we have the button to handle submit for the updating an entry. And that's going to be labeled update. We can just specify a little more, update journal entry. Okay. And then we have delete entry. So this will be a delete button, and we can just do an account query here for the title. There we go. And now since title could be undefined, we're just going to add in a little check here for error handling. So we'll do this, and we're going to do if So we'll just change this a tiny bit. Okay. So we'll do a const. There you go. So if it exists, then it'll actually execute the instruction. Okay. Clean that up a little bit. So now we'll clean up our imports that we don't need. Okay, and then we need to find the name for create entry because it looks like we didn't name it that. So let's go back and see we have update, delete. We have create entry, so let's just make sure it was imported. Okay, so this should actually be update entry. There you go. And then we're gonna have to do the same thing from earlier because title could be undefined. So we're just going to add in a check there. So if title exists, then we'll actually do this. So, and title. There we go. And it looks like this is good to go. So one more check, we're gonna check in on the feature. We just need to make sure we're returning program ID, which we're not, so we'll add program ID in here. And we're good to go. So let's try to build this. So we're gonna navigate into our web app. And we'll run npm run dev and see what we've got going on here. So let's open up a browser and we'll go to our localhost. And you can see our web app is now running on our localhost, port 3000. And here's our app. So this is what the front end looks like when you're using npx create Solana DApp. You have this basic UI. You have the accounts. This shows you your connected wallet account. So this is my DevNet wallet. You have your clusters. Right now I'm connected to DevNet, but I built and deployed my program on LocalNet, so I'm going to change that connection over to local. Okay, and we're just going to request an airdrop, make sure I have funds on local. Then we can click over to our program. And you can see here, program not found, so we're going to go back here and just make sure we have everything correctly updated. So we'll open a new terminal. We'll cd into Anchor. We'll do Anchor build. And then Anchor keys sync, make sure all of the program IDs are connected across the workspace. So, and then we'll just do Anchor deploy, specify the provider cluster to be localhost. So it deploys to local. Local net for Anchor. Localhost is Solana CLI. Okay, so here's our program ID. Let's just refresh this. Okay, so you can see here the program IDs don't match up. So that means something in our data access is pulling an incorrect program ID. So it's probably coming from the counter. So we're going to go back over here to our use counter program, and where is it finding the program ID? So get ID. Cluster, DevNet, public key. So this public key needs to match the public key in our Anchor program. So we'll go back to our Anchor program and just make sure it's connected. So see how they're different? That's where we're going to update. So in the npx create Solana DApp, the one part that doesn't update with Anchor key sync is right here. So you go to your counter exports and you just want to update, oops. You want to update the public key to the new public key. Okay. So now let's see if this updated. We're going to close out this instance and just rerun our we'll cd back to our web. And then we'll run npm run dev. Okay, so now we're on our localhost. we'll go here. I'm going to refresh. Okay. So we're just going to find where it's generating this account. So I'm going to copy this over and Command-Shift-F. And search this. Okay, so here it is. This is what we also need to update. So here you have these TypeScripts, and it has an address that is our old public key. So we'll go in here, take in the public key that we want, that we actually deployed, and I'm going to go into, let's see, how do we do this? We will just paste this here so I have it. We'll go back here, copy this, Command-Shift-F. We're going to paste the one we don't want. We'll click in here, and then we'll paste this one in. Okay. Make sure all of this goes away. Save. Okay. Now we'll go back over here, refresh, and here we go. We have our updated public key. So this is our account. Now we're just going to create a message. So I'm going to do bootcamp. And I'll make the entry learning anchor. And we'll just submit that. It's going to pop up your wallet to sign the transaction. So I'll confirm, and there you go. So there's my entry. It's titled Bootcamp. My message is learning anchor. Now I have the option to either update a journal entry or delete. You can see the update is disabled because I don't have the correct information in the message. So once I start putting something in that field, it'll pop up. So let's update it to I learned anchor, because now I know what I'm doing. And now you can see the button shows up. So I have the ability to update, my wallet comes up, sign the transaction, we'll refresh, and now we have a new message, I learned anchor. And now last thing, delete. So if I don't want this anymore, I'm going to delete it. Now it's gone. So that's everything. We created, we updated, we deleted, and we're able to read on the UI. So we have our fully working CURD app. We have it connected to the front end, and we're able to play around with the UI and test everything. So we did it. Good job, guys.